All right, here we go. Unit 5, Lesson 1. Let me give you an athlete. How about A-Rod? A-Rod did a bunch of steroids, so he might not make the Hall of Fame. Don't cheat. He was one of the best. All right. Here we go. Lesson 1. Unit 5. Sketch the solid of rotation. Formed by rotating the given two-dimensional figure using the horizontal line shown as an axis of rotation. So these come in handy because, like, if you ever work with like a lathe or you want to make chess pieces, stuff like that, maybe you are an artist and you want to create stuff. I can show you the easiest way to do this. You don't need patty paper to finish this problem, but I do want to show you how you can use it. So check this out. You draw the line first. I've never done this. I think it'll work, but now I'm going to trace this line as best I can. Again, it doesn't have to be perfect. You just have to try your best. And I want to show you why patty paper is super helpful for these. Do you need patty paper? No. All right, so I've got it traced, as you can tell. Now, if we rotate via this axis of rotation, this 2D, two-dimensional image will turn into like a 3D solid. And that's the solid of rotation is like the 3D final shape. The axis of rotation is just like, imagine like a rotisserie grill, like where you're spinning a pig. I know that's kind of grim, but that's another like axis of rotation example. So anyways, flip this puppy, keep the line where it was, and then watch this. You can draw a couple points. You want to use a sharp edge, so I'm just going to go like this. And then we'll connect the dots later. This is one way to do it. It's not the only way to do it. But we'll see how it turns out. Okay, I think I got what I needed. Yep, there it is. Okay, so now I'm just gonna connect the dots. I'm just trying to do this as best I can. It doesn't have to be perfect, but if you're making chess pieces, it does, that's for sure. We'll talk about that later. So now you want to use your straight edge because these are going to be connected, right? And so these, and there you go. Boom. See how like a lathe machine? That can create like 3D images. It's pretty cool. And remember, this is the axis of rotation. And if you really want to sink the point home, draw like, make it a 3D. This is the solid of rotation. 3D, kind of looks like a vase of some kind. Okay, cool. Draw a two-dimensional figure, number 2, that could be rotated using a vertical axis of rotation to give the barrel shown. So yeah, like here's a barrel and they want a vertical axis. So I'm gonna go through the middle. So here we go, use a ruler, make it easier. Here's my vertical axis of rotation. And then you could use patty paper for perfection. However, I don't expect you to be perfect. But anyway, here we go. Watch this. You could even just trace it. kind of cool how you can do stuff like this in geometry. Do I expect you to be perfect? No, but I expect you to try your best. I've never actually used patty paper for this problem, but it will look better. Because as you know, when you trace things, they come out a little better than when you hand draw. Hence all my art. Much of it is traced. And you'll start to see, I'm trying to show you that tracing is part of geometry. You don't need to reinvent the wheel. Anyway, there you go. The last thing I missed was the actual axis. So again, that vertical line is the axis of rotation. So let's draw that. And then imagine you just drew it right here. Cool? Can you see that okay? That would be it right there. And then if we rotated via this axis of rotation, this line right here, that's your axis of rotation. A 3D image would be the barrel. All right, patty paper can help you on these. Buy some, it's like 10 bucks. Nothing. All right, you get 1,000 sheets for 10 bucks. All right, this is the most layup question in the world. Match the 2D figure and the axis of rotation with the solid of rotation that can be formed by rotating the figure using that axis. Basically, it's like, all right, you have half a barrel and you rotate it, then it becomes the full barrel, right? We rotated on this axis of rotation and it created the vase in the last two problems. So anyway, we rotate this puppy, like this is the axis right here, this dash line. There's gonna be a circular bottom, right? And every single cross section will be a circle. Anyway, that's a cone. Boom. Cone. Okay, this one's easy. Like, imagine like two circles on the bottom and the top. That's a cylinder. And last but not least, this one, you know, this is a sphere. Easy. Okay, find the area of the shaded region. I looked at this problem earlier. I was like, ooh, this is kind of a beast. But I want to show you what I did. I drew a couple of radii to help. We got to get the whole shaded region, right? Now, what we have here is a semicircle and a rectangle, right? The rectangle is easy. That's just length of 6 times width of 3. So length times width equals area of a rectangle, right? So length 6, width 3 equals area. So our area of the rectangle is 18. So the rectangle is 18, we'll call them square units because they don't give us a unit of measurement. So we got the rectangle, right? Now we're gonna get the semicircle, which is fairly simple. The circle area formula is pi r squared, right? Area of any circle is pi r squared, right? So semicircle will just be pi r squared divided by 2. So that's the semicircle because it's half of a circle, right? Divided by 2. So here we go. Pi radius 3 squared divided by 2. That's going to be the area of our semicircle. So that'll equal 9 pi over 2. And that's the area of the semicircle, 9 pi over 2. Plus the rectangle of 18. So the area of the shaded region is quite simply this plus this. So you can just say 9 pi over 2 plus 18 equals area. And you want to always say square units. That's my final answer. You could simplify this on a calculator. 9 times 3.14. It's going to be a little more than 27 divided by 2 plus 18. But this is okay. You could leave it like that. I'd give you full credit. Now let's do it on the calculator. Clear. So do this one first and then add 18. So go 9 times pi divided by 2 plus 18. 32.14 square units. That would also work. Easy. These are easy, but you got to figure out like the plan. The plan's the hard part. All right. That was 4 problems. We're cooking. Okay, I looked at this one earlier too, and I decided that if I drew this auxiliary line, I would create a rectangle plus a right triangle. And we just add up the areas of these two. Rectangle's easy, 8 times 10. That's 80 square units. This one is just going to be 1/2 the base times the height. The base we know is 10, so 1/2 10 times the height, which we don't know yet. You can't just say 1/2 10h or 5h. You can't just say that. That's not good enough. Because as you know, you can color, label, write, choose, do. Tan 70 equals op adjacent. Tan 70, 2.747, use 3 decimal places, equals op 10 over height adjacent. Cross multiply, h 2.747 equals 10. Divide by 2.747, divide by 2.747. Cross those out, h equals 10 divided by 2.4, 10 divided by 2.747 equals 3.64. And you go back here, area equals 1/2, 10 times your height, which is 3.64. Now you can just leave this number on the calculator, multiply it by 10, divided by 2. Your area is 18.2. That's the right triangle. So now we got to go 18.2 plus 80 for the whole thing, which equals 98.2. So the final answer is the area equals 98.2 square units. I go fast because most of you just want the answer, because we've gotten to the point where people like these problems. All right, cool. Number 6, this stop sign's a regular octagon. It has side lengths of 12. What's the area of the perimeter? Okay, perimeter is easy. That's just 12 times 8 because it's an octagon. So that's 96 inches equals P. So box that. Now area is gonna be tricky. So I have decided I'm gonna do another one. So here we go. So imagine we've got a circle. There's our center. Now octagon, the interior angles are gonna be 360 divided by 8, which is 45, meaning for time's sake, I'm just gonna go fast. Now you could have used a protractor and measured out 8 45-degree angles, but I don't want to lose you. So here we go. We got our 8 vertices. So I'm just going to connect the dots, and then we're going to use some logic to figure out the area. All right, 1, 2, 3, 4. I want to show you like tips and tricks to save you time so you can go hang out with your friends, or I don't know, do whatever it is you do with your free time. Start doing the things that make you happy. Don't be on a device all the time, because it tends to make you unhappy in my experience. But anyway, what I am going to do is we're gonna create one triangle, figure out the area for one of these, and then we'll be good. So this is 12, right? We're gonna draw an altitude real quick. Altitude or auxiliary line just kind of helps you. In this one, these are 90 because it's an altitude. These are 22.5, 45 divided by 2. I will tell you right now, we got a 90, a 22.5 on both of these, meaning they share this side. So because of angle side angle, we have congruent triangles, meaning this is 6 and this is 6. Now, the next thing you got to do is write op. So I'm going to color in one of the angles, 22.5. The 6 is opposite. We have to figure out a height, which is ADJ. This is hypo. We're just gonna forget about hypo for a minute. So, we colored the angle in, we labeled the sides. Now we're gonna write SOHCAHTOA. And we're gonna choose which one we need, the O and the A, so we're gonna use TOA. So you're gonna say tan 22.5. Now where did I get that 22.5 from? Well, 360 divided by 8 is 45. So because we had an angle bisector altitude, how do I know that? Because the two triangles are congruent by angle side angle. That means this angle and this angle are the same. It has to be 45 divided by 2. So you say tan 22.5 equals op ADJ. You compute this. Tan 22.5, 0.414 equals op 6 ADJ height. Cross multiply, h 0.414 equals 6. Divide by 0.414. Cross these out. 6 divided by 0.414 is 14.49. So height is 14.49. Why don't we just call it 14.5 just to make it a little simpler. And then you now have all your stuff. So check this out. Here's another triangle. Now you know this triangle's area equals 1/2 base height, right? So is this one, because that's the formula for all triangles. Now I'm gonna draw a little line right here to make it easier. You now know the base is 12 and the height was 14.5. Now you just plug and play. So let's go up here. Area of one of the triangles, just one of them. So one triangle is 1/2 12 times height 14.5. So here we go. 0.5 times 12 times 14.5 is 87. So area of one triangle is 87. Now you got to figure out how many do we have? Well, it's an octagon, so 1, 2, 3, 4, 5, 6, 7, 8. Multiplied by 8. 696. So the area of the octagon is 696 square units. Final answer. So perimeter was 96 inches. Area is 696 square inches. And that's your final answer. Good job. All right. Number 7, right triangle ABC is shown. Select all expressions equal to the side length of BC. Okie doke. Here we go. Woo. All right. A. I haven't looked at this, so forgive me if I make a mistake. A, they're using Pythagorean, so here we go. 4.9 squared plus, let's just call it BC squared. Does it equal 6 squared? Let's see. BC squared will equal 6 squared minus 4.9 squared. And then we're going to square root both sides. So we get BC equals the square root of 6 squared minus 4.9 squared. Is that this? Nah. Nope. Not good enough. 6 squared minus 4.9 squared, square root of it. Yep, that's that one. Now they're going sin 55. Okay, so there's 55. We colored. We labeled op 80J hypo. So they're using sin 55. So sin 55 will equal 4.9 opposite over 6. So BC is not even part of that. This one you gotta be careful though, because cosine. Let's do, yeah, I'm gonna go ahead and say C is a no-go. Because BC is not even involved in sin. Oh, I may regret that one. Because sin 55 also equals cosine 35, right? You know that from before. So let's see. Let's see about this 35. So cos, let's do cos 35, because that equals the same thing as sin 55. So that would make this 80J, and this op. So cosine 35 is 4.9 over 6. I'm going to go ahead and say this one's off too. All right, now let's go tan 55. So we're back to this one. This is back to op. This is back to adjacent. So tan 55 equals op over 80J. So let's say tan 55 equals 4.9 over BC. BC tan 55 equals 4.9. BC equals 4.9 over tan 55. 4.9 over tan 55. There it is. Boom. That's not the same as this. All right, 6 cos 55. Yikes. Okay, here we go. Back to 55. Cos 55 equals ADJ over hypo. You already know that, so I won't bore you with that. But so cos 55 would equal BC adjacent over 6, meaning that BC cross multiply equals 6 cos 55. Let's see what they got. Boom, right there. BC 6 cos 55, much different than that. I'm gonna say BFG. BFG. That's tough. This is so difficult. Difficulty. I'm gonna say 8 or 9. That's a tough one. If you can get 7, look out. You're powerful. All right, that's it. Unit 5, lesson 1. Practice problems. Keep trying. Just don't give up. Who cares about the difficulty level? Try and see how far you can get. All right, bye.